Hi there. This video is to get you started with the paper plasmid lab, also known as the E. coli insulin factory. So a PDF of the lab looks like this. And if you haven't done so already, or maybe even if you have, you should revisit, read through the background, goals, summary of pages, and instructions, and pause the video while you do that. And when you're done doing that, then come back to the video, okay? So you'll notice that it has several pages, this lab. The first two pages are white, and those are the instructions and the background information. Then there's a pink page, that's the paper plasmid that you're going to make. Then there's a purple page, which is the cell DNA that you're also going to make. There is a green page, which is the restriction enzymes. And then there's a yellow page, which is actually your answer sheet and data sheet. So the first thing you're going to do is, after you've read the instructions and stuff, the instructions tell you to go through and take the pink sheet, and to cut it into strips. So get out your scissors, cut it into strips, and pause the video while you do that. Okay, now you've cut your plasmid into strips. There are 6 of them. There's also this little side sheet piece that talks about the antibiotic resistance sites on the plasmid. So you've cut your plasmid into strips, and you're going to choose 4 of them to make your plasmid out of. One of them that you have to include in your plasmid has the origin of replication site. So I need this strip and then 3 other ones. So choose 3 of those strips. And then what you're going to do is you're going to tape the strips together end to end so that the sequence is going in the same direction. Okay? And then tape that long strip that you have of the 4 pieces of plasmid into a circular loop. Okay? So tape the ends together so it forms a circle. All right? Pause the video while you do that. Come back when you're done. Okay, so got my plasmid cut into strips. I chose my 4 strips, and I've put them in a circular piece of DNA. Okay, so one continuous circular piece of DNA. All right. The next thing I'm going to do is I'm going to set this aside. Your extra pieces of plasmid, you want to hold on to those. Don't throw them away yet. You want to next you're going to take your cell DNA sheet, your purple one, and cut that into strips. Okay? Pause the video while you do that. Come back when you've got it in strips. Okay, I've got my DNA cut into strips. These have numbers on them. You'll see at the top of this one is a 1. Okay? And at the bottom of this one is a 1. These go together in order. The strip that was all the way to the left that has the 1 on the bottom gets taped to the strip that has the 1 on the top of it, like this, okay? And the bottom of this strip that had the 1 on the top has a 2 on it, so the strip that has a 2 at the top gets taped where the 2 is there, and so on. You're going to tape this purple strip of DNA together in one long, continuous 6-part strip that is not in a circle, okay? So tape that together, and when you're done, come back to the video. Okay, so I've taped together my my cell DNA strip into one long straight strip, okay, in sequence. All right, so I have my circular plasmid and I have my purple cell DNA. The circular plasmid is pink, the cell DNA is purple. The next thing it tells you to do is to map your antibiotic resistance site on your answer sheet on this plasmid map here. So I take my pink plasmid, and I notice that the map kind of has an area for where the origin of replication is, and my plasmid that I chose has this one antibiotic resistance site on it. See how it's shaded? That happens to be the antibiotic resistance site for ampicillin resistance, because it's shaded that way. Remember that side strip of paper tells me that's ampicillin resistance. So this ampicillin resistance part of this plasmid needs to be put on my map. Well, here's the origin of replication site, and a little ways up is where the ampicillin resistance is. So I'm going to take a pencil, and I'm going to mark about where that would be on this circular map. So I put a mark maybe about here that says ampicillin resistance. Your plasmid might have more than ampicillin resistance on it. If it does, then mark where those are and label them. Okay? When you've done that, unpause the video and we'll continue. Now, the next thing that you're going to do is you're going to take your green sheet of restriction enzymes and you're going to cut all those out along the dotted lines, okay? 8 of those have a sequence that they recognize, and then 1 of them says ligase on it, all right? So you're going to cut all those out along the dotted lines, and when you do so, come back. I've got all of my antibiotic resistance cards cut out, okay? Now, my next job is kind of the hard part of this lab. I need to go along my plasmid and see if there are any sites on the plasmid sequence that match those restriction enzymes. And I need to do this for all the restriction enzymes. I'm going to start with this one, EcoR1. And what I'm going to do is I'm going to go along the strip of plasmid, and I'm going to see if I find any place where the sequence on the pink strip is the same as the sequence on the green card. So I'll go along that. Aha, I found one. So you'll notice that on the pink strip, the sequence is CTTAAG, just like it is on the green strip, CTTAAG. The other side matches too, GAATTC, GAATTC. So on my plasmid, what I'm going to do is I'm going to mark that off with a pencil, okay, right on the plasmid, just like the dotted line mark is on the green card. So you'll notice this restriction enzyme makes that kind of cut. So I'm going to mark it. I'm also going to mark it on my map. Okay, so where is that in relation to the origin of replication? It's down here somewhere. So I would mark that on my map and what restriction enzyme that is. This one is EcoR1. So EcoR1 makes a cut somewhere down here. Okay, I'm going to continue because this restriction enzyme might recognize more than one part of the plasmid. So I have to go all the way around and see and mark any places where the sequences are the same and put them on my map. Okay? When I've done that with EcoR1 or whatever, and I continue and go all the way through all the rest of them. Ligase doesn't have a sequence, so you don't have to do that. So you have to map 8 restriction enzymes on the plasmid. Once you've mapped them on the plasmid, you can start to fill out this table also. It turns out my EcoR1 cuts the plasmid once, so I put a 1 there. Okay? Maybe I'm going to find out that AVA2 doesn't cut the plasmid at all. Maybe I'm going to find out that HPA2 cuts the plasmid twice. I don't know. Everybody's answer could be different because remember, you selected 3 strips and the origin of replication strip to make up your plasmid and put them in some order. So I don't know how many cuts these are going to make on your plasmid. I only know how many they would make on mine if I go and map it out. So there's a lot of possible answers to this. So once you've mapped out all of your restriction enzymes on your plasmid, you're going to do the same thing on the DNA strip. You're going to go along the DNA strip with your restriction enzyme card and see if you can find any sites that match up, okay? And mark your DNA strip the same way. Let's see if I can find one on here. Yep, there's one right there. The purple DNA strip and the green card have the same sequence. So on the DNA strip, I'm going to mark to make the cut, okay? And I'm going to keep going all the way down because it might make more than one cut. And I'm going to map all the restriction enzymes on the DNA strip also. There isn't a map of the DNA strip. There's only a map for the plasmid. But when I say map on the DNA, I mean make the marks of the restriction enzymes on this, okay? Be a good idea to label them too. So like this sequence is recognized by EcoR1, so I'm probably going to want to write that on there. EcoR1. Same thing with my plasmid. I'm probably going to want to write that on there where I marked it. That's where the sequence is the same for EcoR1. So I'm going to write EcoR1 on that where it cuts. Okay. So once you've mapped everything out, okay, then you can proceed to finish the lab by making your recombinant DNA. I'll make another video later on for that, how to do part B. All right, that's the idea. Okay, so good luck. If you have any questions, contact me.